Welcome back to G Fun Facts Online, where we dive deep into the most mind-bending truths our universe has to offer. Today, we're venturing far beyond our cozy solar system, into the realm of exoplanets. Imagine a world, not unlike Tatooine from Star Wars, basking in the glow of two suns. Now, tilt that picture. Imagine that planet orbiting its twin stars, not in the same flat plane, but perpendicularly, like a cosmic Ferris wheel around a spinning carousel. This isn't just science fiction anymore. It's the cutting edge of exoplanetary cartography, the incredible challenge of mapping these truly alien worlds. Planets orbiting two stars, called circumbinary planets, have always fired up our imaginations. Think of those iconic double sunsets. But in reality, these systems are a gravitational puzzle. Two stars playing tug-of-war makes it tough for planets to form and find a stable path. For a long time, we wondered if such worlds could even exist outside of our stories. Then came Kepler 16b, the first confirmed circumbinary planet. It's a cold, Saturn-sized gas giant, proving these Tatooines are real. Since then, we've found a handful more, each discovery pushing us to rethink how planets are born, especially since most of our models were built around single stars like our Sun. Now, here's where it gets even wilder. Most circumbinary planets we've found orbit roughly in the same plane as their stars. But scientists theorized that stable orbits could also exist in a polar configuration. Picture that planet circling up and over, and down and under its two stars. For ages, this was just a cool idea, though we'd seen hints in the swirling disks of gas and dust where planets form. But then, in April 2025, yes, that recent, came a groundbreaking discovery, the first strong evidence of a polar circumbinary exoplanet. Meet 2M1510 ABB, or just 2M1510b for short. This isn't just any planet. It orbits a pair of young brown dwarfs. Think of them as not quite stars. And its orbit? A mind-boggling 90 degrees to the plane of its twin stellar hosts. This system is incredibly rare. The brown dwarfs themselves are only the second eclipsing pair known, and this planet is the first ever found on such a perpendicular path. It was spotted using the European Southern Observatory's Very Large Telescope, which detected these tiny gravitational nudges on the brown dwarfs, a signature only a planet in this polar setup could create. And believe it or not, studies suggest these polar orbits can be surprisingly stable, sometimes even more stable than flat ones, especially if the stars have elliptical orbits around each other. So we've found these bizarre worlds. But how do we even begin to map them? We can't just point a telescope and see continents or oceans. They're just too far and too small. Astronomers are incredibly clever, though. They use techniques like transit mapping. When a planet passes in front of its star, or behind it, the light changes, and we can learn about its atmosphere, or even create basic temperature maps, especially for planets that are tidally locked, always showing one face to their star. We can also look for how reflected light changes as the planet orbits, giving us albedo maps, showing shiny versus dull spots. As a planet spins, different features rotate into view, causing subtle light changes, which allows for rotational mapping. But for circumbinary planets, it's a whole other level of complexity. You have light from two stars, those stars might eclipse each other, and the planet's transits across both stars won't be regular. For 2M1510b, they didn't even use transits. It was found by the radial velocity method, watching the gravitational tug of the planet on its host, brown dwarfs. Imagine trying to map a planet with two suns moving in a completely different plane. The patterns of light and shadow would be unlike anything in our solar system, creating incredibly dynamic conditions. If we can measure these changes, it might actually give us more information for mapping. What would it be like to live on such a world? The environment on a planet, in a polar orbit around a binary star system, would be utterly alien. Seasons would be driven by the planet's journey over the poles of the binary's orbit, plus its own axial tilt. Daylight would be a complex dance of two suns appearing to move in paths completely unlike Earth's, or even a flat Tatooine. The view from the surface? Stunningly bizarre, with suns rising and setting in ways that would mess with our heads. Could such a world be habitable? That's a huge question. Orbit stability is key. And then there's the radiation from two stars. Kepler 16b, the flat circumbinary, is a cold gas giant, not great for life as we know it. But we've found polar disks of gas and dust, the stuff planets are made of, which means planet formation is possible in these tilted configurations. Even more exciting, we've recently found complex organic molecules, the precursors to life, around a young binary star system. So if a rocky planet existed in a stable polar orbit, in the sweet spot where liquid water could exist, it would be a top candidate in our search for life. Life that would have adapted to some truly unique and spectacular conditions. Pioneering alien cartography is pushing our technology and ingenuity to the limits. The James Webb Space Telescope is already giving us incredible insights into exoplanet atmospheres. Future missions like ESA's Plato and Ariel and NASA's Habitable Worlds Observatory are designed specifically to find and characterize exoplanets, mapping their atmospheres and maybe even surfaces. And don't forget the giant ground-based telescopes. The radial velocity method was key for 2M1510b, but other techniques like looking for tiny changes in the timing of stellar eclipses are also promising for these tilted systems. And to actually make maps, astronomers are developing seriously smart algorithms, even using deep learning, to pull out those faint signals from distant worlds. Why go to all this trouble for these perpendicular worlds? Well, it's not just a cosmic curiosity. These systems are extreme laboratories. Studying how planets form and survive in such crazy gravitational environments tests our theories of planet formation right to their limits. The fact that polar orbits even exist tells us that there are more ways for planets to come into being than we ever imagined. Every new type of exoplanet system we find redefines what we think of as normal. These perpendicular worlds seriously broaden our cosmic horizons. And let's be honest, there's the sheer wonder of it all. The quest to find and map these planets taps into that fundamental human drive to explore and understand. The idea of such bizarre, beautiful landscapes fuels both science and our collective imagination. The discovery of 2M1510b, that amazing planet orbiting its twin brown dwarfs at a right angle, has truly opened a new door in exoplanet exploration. It proves that these polar Tatooines are real. As our telescopes get sharper and our mapping techniques more advanced, we're on the verge of unveiling the incredible details of these tilted worlds. Each new piece of data will help us paint a clearer picture, turning them from distant points of light into unique places, with their own geographies, climates, and who knows, maybe even their own stories. The cartography of these twin sun worlds, orbiting at a cosmic tilt, is just beginning. And it promises a universe even stranger and more wonderful than we can currently comprehend. Thanks for tuning in to G Fun Facts Online. Join us next time as we continue to explore the amazing universe around us.